Hi, we are going to explain our poster, The Science Inside a Battery. Our team is Salvador Monroy, Diego Cano, José Manuel Becerril, Raúl Vargas. Well, the objective of this is to explain our problem situation. That is, we are going to commission to design a galvanic cell in order to build a homemade battery, which requires a minimum of 3 volts for optimal performance. Well, a battery stores energy and converts chemical energy into electricity through electrochemical reactions. The charge capacity of a battery is measured in amperes per hour, while voltage is measured in volts. Well, this process of charging a battery involves feeding it with electrical current, while discharging it involves restoring the chemical differences in the cell.
Talking about the methodology, we consider the concept of the redox reaction. The redox reaction involves an oxidant or oxidizing agent and a reductant or reducing agent. The oxidant takes the electron and oxidizes the reductant. The reductant, however, donates the electron and reduces the oxidant. Considering that a battery requires two cells, one that is positive, which is the cathode, one negative, which is the anode, a conductive electrolyte, and a container for joining all the materials, we decided to bring the following materials for the class. We brought a piece of copper, zinc pieces, electric cable, Gerber containers, and we prepared potassium nitrate solutions. We decided to use copper and zinc because of their capacity at the time of having electric contact and doing the analytical way of building the semi-reactions for the copper and zinc. We argued and agreed that the copper was the cathode and the zinc was the anode. With the help of the tables, we found out that the copper reaction was above the zinc reaction. And when we have two cells, the one that is the cathode is the one that is above the other cell. So the copper reduces the zinc and loses electrons, and on the other hand, the zinc oxidizes the copper and gains electrons. Having the cells ready, we must have selected our electrolyte for the battery, and we started searching about the salt bridge for being our electrolyte. That's why we selected the potassium nitrate. A salt bridge is a device used to connect the oxidation and reduction half cells of a galvanic cell, which is a type of electrochemical cell. It maintains electrical neutrality within the internal circuit, preventing the cell from rapidly running its reaction to equilibrium. If no salt bridge were present, the solution in one half cell would accumulate negative charge, and in the solution, the other half would accumulate positive charge as the reaction proceeded, quickly preventing further reaction and hence production of electricity. The process that we took was the following. We cut 5 small rectangle pieces of copper. We cut and peeled 5 cables that were measured approximately about 10 centimeters. We put together the copper on one side of the cable and the zinc on the other side of the cable. We made solutions of potassium nitrate using 1 mole and 35 milliliters of water. And finally, immerse the wire with the zinc and copper in the solutions, like in the image that we showed here. That's the part of methodology.
Okay. Okay, as results, we have that we're able to power our LED using the battery built by our team. For this experiment, which was capable of generating a voltage slightly above 3 volts, reaching our initial goal. Nonetheless, we were unable to make the motor work. This is because the motor needs 100 amperes and 3 volts, and our battery only generates 0.09 amperes of current while the motor. This is because the current of all our battery doesn't current in all the circuit. So to we have a solution to this that is make a more use more bigger pieces of copper and zinc and more unique solution. In our battery could result in more to generate more amperes and potentially make our motor works.
So in conclusion, we have to say that we are very pleased with the work we have presented as a team, and we also think it's important to acknowledge that even though we were able to turn on an LED with the battery that we designed, this wasn't powerful enough in order to turn on the engine as we first intended to. So there is still a bit of work that has to be done in order for us to consider this experiment as fully successful. As a team, we can say that we are very aware of the damage that many energy sources cause to the environment, especially the production of electricity, which is a significant contributor to pollution and greenhouse gas emissions.